Good morning. This is Ms. Billerbeck, and we are going to talk about 7.6, factoring ax squared plus bx plus c when a does not equal 1. So for the first example, we're going to factor the trinomial 5x squared minus 3x plus 50. So if we pull out the greatest common factor, whoops. That's not a 3, silly me. That's 5 times 7 times x. And then plus 2 times 5 times 5. So when we pull the greatest common factor, we see they all have a 5. So we can pull that out. So our greatest common factor is going to be 5. So when we factor this, then we pull the 5 out, and what's left is x squared minus, and then we have a 7x, and then 2 times 5 is 10. So now we can factor this trinomial using the diamond and the box. Now, if we had left the greatest common factor in there, that would have caused a lot of trouble with this box technique. They would have squared this common factor, which would have been a huge problem. So let's go ahead and look at this. So A is 1, B is -7, and C is 10. So this is A times C, so 1 times 10 is 10. And then we have -7. So if we look at the factors of 10, that's 1 times 10 and 2 times 5. So in order to get a 7, they would both have to be -2 and -5. So it takes 2 negatives to make that positive. So we have -2 plus -5 is -7. So we put our first term here, which is x squared, last term plus 10, but we note that this was a negative that made that positive. So that's an important note because we need to share some negatives here. So we have -2x for this diagonal and -5x for this diagonal. So when we note there's a negative to make that positive, we share the negative with this column and this row. So this is going to give us a -5 as a greatest common factor. And the greatest common factor here is x. We have a greatest common factor here of x, and -2 and -10 would be -2. So this, our final answer then for factoring this trinomial will be 5. We don't want to forget about that 5 that we already took out, which gets forgotten quite a bit, so please don't. Then we're going to write x minus 2 times x minus 5. So that would be the factored form. When it's completely factored. All right, let's try another one. All right, so we have 2 times 3 times x times x times x plus 2 times 3 times 5 times x plus 2 times 2 times 2 times 3 times x. Now, if you're wondering where I got these numbers, 2 times 2 times 2 is 8. 8 times 3 is 24. So these are the prime factors of 24, x. And then the prime factors of 30 is 2 times 3 is 6. 6 times 5 is 30. And then we have x squared. And 2 times 3, of course, is 6. So we look at what do they have in common? Well, they have, it looks like they all have 2 times 3 times x. So we have a 2 times 3 here. We'll take that x, and we have 2 times 3x here. So now our greatest common factor is going to be 6x. So we can pull 6x out. And what's left is x squared plus 5x, and then plus 4. So we'll do a diamond box on that. So we have A equals 1, B equals 5, and C equals 4. So 1 times 4 goes here, so that's 4. 5 is here. So the factors of 5 are 4, are 1 and 4, and 2 and 2. But 2 plus 2 is 4, so that doesn't work. But 1 plus 4 does equal 5, so 1 and 4 will be what we're looking for when we make the box. So let's make this box. We're going to put the first term here, x squared, last term here, 4, then the side terms, 1x and 4x. So our greatest common factor for this column will be x. For this column will be plus 4. For this row, it'll be x. And for this row, well, 1 and 4, the only greatest common, or the only factor 1 and 4 have is 1. So when it doesn't look like they have anything in common, 1 always works because 1 is a factor of all numbers. So we originally took a 6x out, so let's not forget about it. So now when we write our final answer, we have 6x, then x plus 1 times x plus 4. And that is our factored form of this trinomial. This cubic trinomial, by the way. All right, sometimes we don't have a greatest common factor to worry about. So 10, 17, and 3 do not have a greatest common factor. So when we go to the diamond box, we don't have to worry about pulling out a greatest common factor before we factor. But this also makes us need the box for, to solve this type of quadratic trinomial. So we're going to do 10 times 3. So A times C for here is going to be 30, and then 17's here. Now, sometimes it's harder to see what our factors are. So we're going to do for these two spots. So we'll do factors of 30 and sums of factors here. All right, so when we take those two things, we have factors 1 and 30. So the sum of that is 31. Then we have 2 times 15, and the sum is 17. And hey, that's what we were looking for. So we found it. Now we don't need to go on. But if we were just practicing factors of 30, the next one would be 5 and 6, which it sums as 11. So we found what we were looking for. So we're going to do the box. With that, let me make a little more room over here. So, I'm going to put a 2 and a 15 right there. Okay, so 2 times 15 is 30, 2 plus 15 is 17. So now I've put the first term here. So I have 10x squared. The last term's here, 3. Let me make that a little bit so you can read that a bit better. So 10x squared there. Now you can see it. All right, and then the last term's here. Now this is 2x, and then we have 15x here. So we look at our greatest common factor between 10x squared and 2x, and that's 2x. 15x and 3 has a plus 3, and 10x squared and 15x has a 5x, and then 2x and 3 only have positive 1 as a factor. So we see that this one is going to factor as 2x plus 3 times 5x plus 1. Now we can quickly check this. We have 2x times 5x is 10x squared. 2x times 1 is 2x. 3 times 5x is 15x. So 2x and 15x is 17x. And 3 times 1 is 3. So it works. All right, so this one we have A, B equals 1, and C. So we do our diamond. We have 2 times negative 21, so that's negative 42. And then this one, B, is 1. So we're looking for factors of 42 that are only 1 apart. Well, 42 is 6 times 7. Those are 1 apart. Well, one of them has to be negative to produce a negative. And then it needs to be the larger one needs to be positive to produce a positive sum. So with that, we can choose 7 and negative 6. So 7 plus negative 6 is 1, and 7 times negative 6 is negative 42. So now let's do our box. So our first term, 2x squared, will be here, then negative 21. We have 7x. And negative 6x. So 2x squared and 7x would be just x as a common factor. Negative 6x and negative 21 is negative 3. And 2x squared and negative 6x would be 2x. And 7x and negative 3 would be just positive 7. Okay, as a greatest common factor. So the factored form of this would be 2x plus 7 times x minus 3. So let's do a quick check. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. Plus 7x gives us just x. And then 7 times negative 3 is 21. So it checks. All right, so let's factor these trinomials using substitution. So this is a new technique that for me to use, but I looked at it and I'm like, I see the merit. I haven't used it, but it does have some merit. So if this is a 2, we're going to multiply everything by 2. So then we have 4x squared minus 2x minus 12. Now, if we note, this is the same thing as 2x squared minus 2x minus 12. So now we can say that P equals, I forgot to erase that. P equals 2x. All right, so at that point, what we can do is substitute the P squared minus P minus 12. So we have much simpler trinomial to solve. This quadratic's much easier to solve than this quadratic. So we're going to put in A is 1 times negative 12. And that's negative 12. P is negative 1. And then we know that the factors are 2 apart. So that'd be 3 and 4, where the 4 is negative and the 3 is not. So negative 4 plus 3 is negative 1. And negative 4 times 3 is negative 12. So that's how you find your factors quickly. If this sum is so close together like that, then you know the two factors have to be very close together. Especially if you have a negative there, then you know that it's a difference. So their difference is not much. So now we can put in, this is p squared. There's a negative 12 here, negative 4p, and then 3p. So when we pull out our factors, we have p plus 3, p, and negative 4. So we can factor this one here as p plus 3 times p minus 4. And we remember we originally substituted that. So now we can put it back in there. So we have 2x plus 3 and 2x minus 4. But we might notice that this has a common factor here of 2. So we can take the 2 out of this because this is 2 times x and 2 minus 2 times 2. So we need to take that factor out. Otherwise, we haven't factored our trinomial completely. So when we take that factor out, we have 2 times 2x plus 3. And then this leaves just x. When we take this 2 out, that just leaves x minus 2. Okay, but we just randomly multiplied by this 2 in the beginning. So, and now we have this 2 out here. So now if we say, hey, I don't want to multiply by that 2 anymore, or you can divide by the 2 at this point, but at this point, you can just remember that you randomly multiplied by 2 to make this square of 2x squared. So now we can divide it by 2, and our final answer will be 2x plus 3 times x minus 2. Okay, so that's the substitution technique. So let's try that one more time, since that's a new technique for me too, because I'm used to use, I'm a diamond box person all the way. It's always great to have many tools in your tool belt. So this one, we're going to just randomly multiply by 10x squared plus 3x minus 1. So 10 times 10x squared. Okay, so that gives us 100x squared plus 30x minus 10 when we multiply that out. So this is 10x squared plus 3 times 10x, and then minus 10. So we're going to say p equals 10x. All right, so now we can have p squared minus 3p minus 10 and do our diamond and our box. All right, so we have put our 1 times negative 10, which gives us negative 10, and negative 3. So when we look at the factors of 10, that's 1 times 10 and 2 times 5. And we look at which ones are 3 apart. Well, that's 2 and 5. And to get the negative, the 5 would have to be the one to be negative. So negative 5 times 2 is negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So now we have that. So let's put p squared and minus 10 here, the first and the last terms here. And we'll put the diagonals in and take our factors, greatest common factors out. Right, so we see that this is factoring as p plus 2, and then we have p minus 5. So let's put this back in with the p being 10x. So we have 10x plus 2 times 10x minus 5. Now, each of these has a different common factor. So this is 2 times 5x plus 2. So that has a common factor of 2 in here. And this one has 2 times 5 times x minus 5. So this one has the 5 as the greatest common factor. So we have to take a 2 times 5 out. And that leaves me a 5x here. And then 2 divided by 2 is just 1. And then this is 2 times x that's left over when we take the 5 out. And 5 divided by 5 is 1. So we have 10 times 5x plus 1 times 2x minus 1. Since we did randomly multiply by a 10 because it matched that 10, now we can divide by 10. So our final answer is just going to be this. Okay, so let's check it. So 5x times 2x is 10x squared. 5x times -1 is -5x, and 1 times -2x is 1 times 2x is 2x. So -5x plus 2x is -3x. Did I? Oh, look at that. Good thing I checked, huh? Okay. So it ended up, this is supposed to be a plus, which would switch these signs. All right, so good thing I checked. Hey. All right, so that changes this to a negative and this to a positive. Yeah, so you have to be careful when you're transferring things. Make sure you do it right. So that makes all these negatives. Checking is important. That's why we use pencil, or in my case, dry erase pens that are easily erased. Because no one is perfect. Okay, let's check this again. So 5x times 2x is 10x squared. 5x times 1 is 5x. -1 times 2 is -2x. 5x minus 2x is 3x. Yay! And then -1 times 1 is -1. So now we have the right answer. All right, you have a wonderful day. Bye-bye.